Look at this dry, dusty basin. 3.5 billion years ago, this exact spot was a massive lake, flooding with fresh water. This picture shows the Curiosity rover, which proved that ancient Mars possessed all 6 chemical ingredients necessary to support life: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, often grouped together as chnops. But having the ingredients for a cake is very different from proving someone actually baked one. We know the chemistry existed, but we still haven't found actual proof that alien microbes lived there. If we want to send human scientists to look for that proof themselves, we run into a massive roadblock. Right now, there is no way for an astronaut to breathe on the Martian surface, let alone refuel a rocket to get back home. That is exactly why NASA built Perseverance. It is a 1-ton laboratory on wheels, designed to act as an advanced scout to tackle both of these massive challenges head-on. For decades, we have been studying the red planet from a distance. With this mission, we are taking the concrete steps required to actively prepare the Martian surface for human arrival. Perseverance landed in Jezero Crater because billions of years ago, a river flowed into a lake here, creating a sprawling delta. On Earth, river sediments settle to the bottom and trap tiny organic materials in the mud. Since life on Mars would have been microscopic, we aren't hunting for dinosaur bones. We are looking for stromatolites. These are layered rock structures created by ancient colonies of mucus-like bacteria that trapped sediment over millions of years. This image shows what living stromatolites look like right here on Earth. Notice how they form these lumpy, rippled shapes in the shallow water. If life existed in Jezero Crater, it likely left behind very similar fossilized bumps in the rocks. To spot these tiny biological signatures, Perseverance is packed with 23 specialized cameras. They can zoom in on the Martian terrain to capture details as small as a grain of salt. Identifying these specific, convoluted layers in Jezero Crater would signify that biology once evolved on a planet other than our own. Even 23 cameras cannot definitively verify a microscopic alien fossil. To be absolutely certain, scientists need to study the physical rocks inside high-powered laboratories on Earth. This photograph from NASA's cleanroom shows engineers in protective suits assembling the rover's sample tubes. These gold-coated cylinders are incredibly sterile, ensuring that we don't accidentally mistake a hitchhiking Earth microbe for a Martian discovery. Perseverance is currently drilling into the Martian crust, sealing small rock cores inside those pristine tubes, and dropping them onto the dusty surface like a trail of scientific breadcrumbs. This diagram illustrates the next phase of the mission. Sometime in the next decade, a smaller Fetch rover will land, autonomously navigate to the dropped tubes, and carefully load them into the payload bay of a miniature rocket. That rocket will blast off the Martian surface and toss the sample capsule into orbit. An intercepting spacecraft will swallow it up and carry the cargo the rest of the way home. It is an incredibly complex international relay race spanning millions of miles, and right now it is the only viable path we have to hold a pristine piece of Mars in our hands. While the rover hunts for fossils, it is also carrying a suite of experimental hardware designed to keep future astronauts alive. One of those experiments is a tiny helicopter named Ingenuity. Flying on Mars is notoriously difficult because the atmosphere is roughly 100 times thinner than Earth's, which gives standard rotor blades almost no air to push against to create lift. This image shows the shadow of Ingenuity hovering above the Martian dirt. By using oversized blades spinning at incredibly high speeds, it successfully achieved powered, controlled flight on an alien world. This photograph displays MOXIE, a gold-plated instrument being lowered into the belly of the rover. MOXIE functions like a mechanical tree. It sucks in the toxic, carbon dioxide-rich Martian air, splits the chemical bonds, and produces pure, breathable oxygen. This diagram shows exactly why MOXIE is critical. Launching a crew of 4 off the surface of Mars requires 25 tons of liquid oxygen for the rocket fuel alone. We simply cannot carry that much extra weight all the way from Earth. If we can manufacture propellant and survey the terrain from the air, we remove the 2 greatest obstacles to landing a crew. Perseverance is effectively testing the life support systems required to turn Mars into a habitable frontier. All of this futuristic technology is operating millions of miles away, but it was assembled by thousands of dedicated people facing a massive crisis right here on Earth. This photo shows a mission control engineer working during the height of the COVID-19 lockdowns. The team had to navigate intense safety protocols and remote work, knowing that if they missed their narrow planetary launch window, they would have to wait 2 full years for another chance. This image captures the Atlas V rocket blasting off against a clear blue sky. It stands as a triumph of coordination, showing that a mission of this scale can move forward even through a global crisis. Perseverance is doing exactly what its name implies. It is laying the physical and technical groundwork to ensure that humanity eventually becomes a multiplanetary species. If you want to keep tracking the rover's progress, hit that subscribe button, give this video a like, and let me know down in the comments what you think we'll find inside those sample tubes. Thanks for watching, and I'll see you in the next one.